Okay, this class is going to be more of a bonus class rather than an actual class. You don't actually have to follow this class like this lecture if you are good with pointers and arrays. And in the next video, I'm going to make two videos because I have to prepare for the other one. So yeah, another one I want to talk about is Boolean algebra. So these ones are going to help you with your CO5, and this one is probably going to help you with CO7. You can do it in other ways, but I prefer doing it that way. So it's up to you how you want to do it. So in this video, I'm going to talk about the pointers and pointer arrays. So I know pointers is a very complicated topic, and you will have a very better understanding. I hope you will have a better understanding of it when we are going through the assembly. But like for now, I will try to clear as many misconception you might have for pointers. So let's get started. So why pointers? Okay, so our course is about like C, right? And C works with the machines, like very close to the machines. No other languages, like high level languages, work so close to the machine as much as C. And one of the greatest feature of C is pointers. The other programming languages uses something called reference. In Java, you have already used that. So, but in C, we are using pointers. And pointers are direct memory locations, like literally a address from the address space, which will be explained in the assembly more clearly. But for now, you can think of your memory in RAM like this. Think of it as a chunk of memories. Okay, so and each memory is pointed by has a memory address. For example, this one is going to be something like 0000. This one is going to be 0001. And so on. That's how it's going to work. Okay, so whenever you declare some sort of like variable, for example, I am going to declare a uint 8t. It's going to named a, and I'm going to give it the value of 2. So if I do something like this, what the compiler or OS is going to do is get a empty memory address, go there and put this value over here. So it's going to be like 00000010. So this is the representation of this. So your a is basically stored here. So that's how normally your variables work. So so where does the pointer come in? So the pointer comes in like this. Whenever you write something like a ampersand, you are getting this address. And if you write a pointer which points here, so that's going to be a completely different memory location. Over there, P is going to exist, and P is going to point here because P has a value that's stored is like this, and that one points to here. That's basically what's happening in this line. Whenever you are pointing a variable with a pointer, this is what happens. It's pointing to here, which has the value of a, which is 2. And whenever you write something like p like this, you are basically accessing the value that's stored here. This is basically the basic, like the most basic idea of a pointer. You have a value, like variable, which has a value. You can access the address where this value is stored by doing ampersand a, and you can point it with a pointer. And if you want to access that value with a pointer, you dereference it by using star pointer. I hope that makes sense. Now, there's a few more other things. So one important thing about pointers is, okay. Um, so yeah, one important thing about the pointer is type. So if its type is like this, sorry, my bad. If it's something like this, we're telling it that the pointer is going to point to a memory location and only going to get 8 bits or 1 byte. Okay, but if we do something like this, it's telling the compiler that we are going to use a pointer to point to one memory location, but when we retrieve the value, it's going to take two like value combined, like combined value of two memory locations. So for example, this one, it's going to point to here, like let's see, our value is something. Okay, I'm not going to write the whole thing. I'm just going to write like in hexadecimal O, and for example, this is OA, and this is something like 1 2 3 4 5 6 and so on. Okay, so whenever P is just uint 8, it's going to tell the compiler that it's going to point to one memory location and just going to retrieve one data, which is this. But if it's uint 16, it's going to take two data. So basically, in that case, it's going to point to this thing. The memory address itself is this, but whenever it retrieves the data, it's going to combine them, which is in this case 120A. This is going to be your output. And if we tell it to make it like uint 32, like something like this, it's going to take 4 of them. So it's going to be like 56, 34, 120. So depending on the type of your pointer, this whole thing is going to change. Okay. I hope that clears a few things up. So that's the idea of pointer, like why we need the data type and how pointer is going to like interact with each other. Okay, so now the topic I'm going to focus on is pointers and arrays. See what I did there? Anyway, so the idea of pointers and arrays are basically the same. Whenever you're writing a array, you're basically creating a pointer. This A is a pointer which points to 10 consecutive memories. So the first memory is A0, then it's going to be A1, the next one, and so on. So A is a, like you can call it a static array, because you cannot actually change the address it's pointing to. But a normal pointer like P can point to A, and later it can point to another array B10. That's completely possible for P. But for A, whenever you're declaring it like this, its address is static. It's not going to be able to change. You can only access the data it was given. Okay? So we already know that the notation, normal notation of arrays are like this, but you can also use the pointer notation. These two are equivalent. You can write A1 and so on. But what you cannot do is do something like this. This is not going to work, because remember, A is fixed. A cannot move from here. So this is not going to work. But if you had something like this, you could easily do P++, and it's going to point to the next pointer and so on. So that's the biggest difference between P and A. Another thing to point over here is, remember in the like just a few minutes ago I mentioned that you can actually do like you actually tell the compiler how many memory locations are going to be accessed by a pointer. So this part is going to be important for your CO5 assignment, especially the fourth function, which is sum of 16. So the idea is kind of like this. You have consecutive memory locations. Okay, this is going to be OX 0 0 0 1 0 0 0 2 0 0 0 3 and so on. But just think that they kept going. These are the data that's like stored over here. Okay, so if you're accessing them with uint, like with this, you are just going to access one data at a time, because it tells the compiler that it's uint 8, so it's going to take in 1 byte at a time. Okay, but you can actually do typecasting and tell it to take 2 bytes at a time. So by typecasting a into uint 16, it's going to take 2 bytes at the same time. So you do not have to do anything manually. You just do some sort of typecasting and it's going to work. This is the basic idea of typecasting. And remember, if you typecast a and do +1, it's going to skip 1 byte. Why do you think that happens? I will let you answer that by yourself, because I'm giving away too many stuff already. But that's the idea. I hope that this gives you an insight of like why typecasting is needed, or how you can actually use that typecasting in your assignment. Okay, so I hope that answers some of your questions, and if you have any other questions, ask me in Piazza. And in the next video, I'm going to, like, honestly, I don't know what else to talk about pointer at this point, unless you ask me, because the biggest problem with the online class is like I don't know what the students are struggling with or what sort of questions they have. So I just like answer it in a more general way, and I hope that if you like come up with some questions, or there are some like misunderstanding or anything like that, you will write them in Piazza or ask me directly in my office or where nobody shows up. Anyway, so yeah, I hope that gave you a better understanding of the pointers. So yeah, in the next video, I'm going to talk about Boolean algebras in more in depth. And remember, these are not in the slides, like they are, but not the way I'm explaining it. So the video resource is all you have. I might be able to give you better resources. If you need them, please ask me. Okay.